Hey guys, how are you? Trying something a little different this week. First, I'm standing up instead of sitting down. And second is I'm trying to post it a little bit later on Monday so that you don't have quite so many assignments when you sign in Monday morning. I want to get feedback from you if you like that. So I'm going to be putting out a little survey to get a feel for if you prefer it posted on Monday morning so you can see everything you got going on, or if you like this better where it's staggered a little bit from your other classes. We are going to just do a quick recap of what we learned last week, and then we're going to transition the same idea, but into using notation only, okay? So again, we're still on conditional probability. So that's the idea that your probability is based on something already happening. So let's review what that means, okay? This symbol right here, P, okay, parenthesis B, and then that line A, means, the way you would read it, is the probability of B given A. You're going to want to write these notes down. Okay, you don't have to worry about this part, but you're going to want to write these down. So I'll take a picture of it and post it to the Google Classroom assignment in case you can't see it well. So the way you would read this is the probability of B given A. Okay, I'll say that again. The probability of B given A. So this line means given. Okay, you may also see that as given that or out of. Okay, the idea is that A is the whole world you're looking at. Okay, you're limiting every possible thing to only looking at A. What does that mean? Well, that means what's the probability that B happens given that A already happened? Okay, you're only in the world of A. So remember when we did the highlighting and we highlighted the A, that one row, that would be the A. Okay, so that's what you're highlighting. Here's the same table we had from last week. You don't have to write this table down. I just want to use it as an example. So again, we're looking at COVID patients. This is from 2 weeks ago, this data, so it's definitely a little bit old. But this is broken down by age category because we all know that COVID infection affects people in different age groups differently. So this is the tested positive. This is the did not test positive. It doesn't mean tested negative. It means either didn't get tested or tested negative, okay? If you look at it, the 18 to 44 and 45 to 64 are both very, very close together. They're like 56,400 number of cases. So you might think like, oh, people in those age categories have similar responses to COVID. But we're going to see that that's not actually the case when you look at all of this data. So what you want to do, what we're going to be asked to do first is this. The first thing we're asked is P of P. That means the probability that someone tested positive. Notice that I gave each thing a letter so that we could then use notation to describe it. Okay, so the first thing I'm going to look at is what's the probability that someone tested positive. So I'm going to look at all the tested positive, 152. This is not a good color to use. Okay. 152, 904, out of all of the people in New York City. 8,632,000. Okay, and then I'm just going to divide that. 152 divided by 8,632,000. And I get 152,904 divided by 8,632. Sorry, my battery's dying. And you get approximately, a little approximate sign, 0.0177. Okay. Now I have what's the probability that someone tested positive given that they are in the B age group between 18 to 44. So now I am limiting myself. I would highlight only this, okay, world. And now I'm saying what's the probability that they test positive only out of this age group. So that would be the tested positive, 474, out of the total in that age group, 3,494,000. Okay. 56,474 by 3,494,000. Okay, and that's 0.0162. Then we have what's the probability of P given C. That means the probability that they test positive given that they're in the C age group. So now I would highlight this group. So I'm looking at the positive, okay, and that age group, given that they are in that age group. So it would be 56, 428. That's this one right here out of the total in that age group. Okay, 56, 428 divided by 2,113,000. Now we're at 0.0267. That's almost double, okay? So now you can see that these numbers, even though they look similar, are not at all the same. So again, that's conditional probability. You're not looking at just the total tested positive, but you're saying within a certain group, what's the probability that that happened? Now we're going to learn how to do that with symbols. Okay. So to calculate conditional probability using notation, again, I'll take a picture of this and post it. The probability of B given A is equal to the probability of A and B, so that's both of those things happening, given that A has happened, so the total probability of A. So A and B, that's this one right here, okay, that's A and B. And then B is just this one right here, the total of B, okay? That's what this is saying. So in this case, it's A and B, right? And then this number is always that one. So that's the world you're in, okay, given that A already happened. So that's the A total, and then both of them. So another thing that we want to remember, this was in the first notes we did on probability, is the probability of A and B happening. Well, if two things happen, that means that, let's say I roll the dice and I toss a coin, you would find the probability of each and multiply them together. So the probability of A and B, and that's a symbol for and, is equal to the probability of A times the probability of B. This is all going to be important now that we apply it, okay? So now we're going to do a little bit of practice. So let's say that they give me the probability of A equals 0.75 and the probability of B equals 0.22. And they want me to find the probability of B given A. All right, so what I'm going to do is I'm going to find the formula, which we just said is this formula right here, okay? So this would be the probability of B and A over, and then this is the world you're in, the probability of A. This one's a little different. This again would be the probability of B and A or A and B, doesn't matter. But now it's given that B happened, so this would be probability of B on the bottom. Okay, so how do we find the probability of B and A? Well, remember that we just said to find that probability, you multiply probability of A times probability of B. Okay, so we would do P of A times P of B, which in this case is 0.75 times 0.22. So in my calculator, it's 0.165, so that's 0.165 over the probability of A is 0.75. And then I just divide that. 0.22. Now let's do this one. So the probability of A and B, we actually just found that. It's A times B. So that's 0.165 over the probability of B. That's 0.22. And then we just divide that. And we get 0.75. You may notice something interesting. If the events are independent, meaning that A and B don't affect each other and don't, cause the other to happen, then the probability of B given A, which was right here, okay, wound up to be the same as the probability of B. That was the one in front. And in this case, the probability of A given B, which equaled 0.75, wound up to be the probability of A. Okay, Let's do 2 more practice just to make sure. So let's say they give us the probability of A, and they give us the probability of A and B. That's a symbol for and, okay? I have to find the probability of B. So I'm going to go to this one because this one has a formula. Probability of A and B. So each time you're using formulas, so that's probability of A times the probability of B. And now I just plug everything in that I can. So I know the probability of A and B. It's 0.135. I know the probability of A. It's 0.45. I don't know the probability of B, so I keep that probability of B. And now I have to solve. So to get probability of B by itself, that's like a variable, I would divide by 0.45, and whatever you do to one side, you got to do to the other. And so 0.135 divided by 0.45 is equal to 0.3. And that's how you can find that. Last thing I'm going to show you is if we have the probability of A and the probability of B given A. Find the probability of B. Okay. Okay, so let's say they gave us the probability of A and they gave us the probability of B given A. Well, remember we said if the events are independent, we noticed that the probability of A given B was going to be the same as the probability of A. So the one in front. So here, if I know this given, the probability of B given A, this is going to be the same as the probability of B. So that means my probability of B is also going to be equal to 0.09 because these are independent events. Okay, let's say I wanted to find the probability of B and A. You can do it 2 ways. You can, if you already found B, you can just multiply them together. Or you can use this formula. Remember that the probability of B given A equals the probability of B and A over, the second one, the probability of A. Now we just plug in. Probability of B given A, that was given to me. That's 0.09. I don't know the probability of B and A. I keep that as is. Probability of A was given to me. Now to get this by itself, I just have to multiply both sides times whatever the denominator is. And I just do 0.5 times 0.09, and I would get 0.045, they would cancel on this side, equals the probability of B given A. So in probability, we do a lot of manipulations of formulas, and that's what we're going to practice this week. Just a lot of those manipulations. Have fun, take some good notes, and I'll see you on Wednesday.